So we've already said empirical formula is the simplest formula, just showing simple number ratios, while molecular formula is formula that is showing the actual atoms that have participated in forming that compound. So a certain compound contains 52.23% carbon, 6.29% hydrogen, and 37.46 oxygen. Now imagine they didn't give you this percentage. All you do is, if you add this and this plus what is missing, should give you 100, so you can capture the missing one. And its molar mass is given as 256.26 grams per mole. Find its empirical and molecular formula. So the first thing is, let's find the empirical formula. To be able to get the empirical formula, first we'll put a portion where we're going to show elements. What are the elements which we have in this question? Please write them in the order they've been given. The first one is carbon, followed by hydrogen, and then oxygen, like that. After that, and then we are going to put a portion for percentage mass. So these percentages which you've been given are percentage by mass, or the percentage composition. Remember, when you are finding percentage composition, we are using the masses. So the first one, that is 52.23, and then we have got 6.29, and then we have got, let me use a different color, 52.23, 6.29, and then you've got 37.46. And then after then, don't convert this mass to, which is given in percentage, to anything else. Just the same way it is been given in percentage, now you can find the moles. And remember, how do you find number of moles? Number of moles is given by mass over molar mass. So this is the mass. The same percentage mass given is the one we take as the mass. And then we divide by the molar mass. What is the molar mass for carbon? You check now on the periodic table. If you've got a periodic table, if you can just check through. So carbon has got a mass that we use as 12.0107. So what we are going to do is 52.23 divided by 12.0107. You can confirm what you get there for carbon, the moles. Okay, 4.348. And then we are going to go to hydrogen. Hydrogen, the mass given is 6.29 divided by the molar mass. Molar mass for hydrogen is 1.008. So that is going to give us 6.24. And then now we're going to go to oxygen. The mass given, that's the 7.46, divide by the molar mass for oxygen, which is 15.9994. Can punch that. 2.34. Okay. Now after doing this, we are going to look at finding the mole ratio. We'll just look at the number of moles and which one is the smallest number. Then you're going to divide everything by that smallest number. So from what we can see, what's the smallest number here? That you are going to use to divide everything by. So the smallest number of moles is 2.34. So divide everything by 2.34. So starting by itself, 2.34 divided by 2.34, that will give us a 1. And then the next, divide 6.24 by 2.34. And then also divide 4.348 by the same 2.34. So divide everything by the smallest moles. So what are we finding? $1.85. Okay. And then the other one, 2.67. Can you give maybe more values apart from that? 2.6. 2 point what? Okay, this is very important. So I'm going to put here. Now this one, 1.85, I can round it off. That is going to give us, round it off to the nearest one number. That will give us a 2. Now for the 2.66, I'll not round it off. The reason is simple. When you see these numbers like these, which are repeating like that, please don't rush in rounding off. You're going to find the wrong answer. So what you are going to do is you are going to express this number as a fraction. You can just go on your calculator, write 2.6666, and then you press where there is a fraction symbol. You see what it's going to give you as a fraction. Has anyone done it? So when you want to express a number in fraction, so you just let this number be equated to x. So you say x is equal to 2.6. So I'll put a bar because 6 is repeating itself. And then I'll multiply by 1 by a 10 so that the decimal point goes behind here. So that will be x times 10, that will be 10x. And then 2.6 times 10, that will be 26 point. Since the 6 is repeating, it will still repeat like that. And then what I'll do is I'll subtract these two. So 10x minus x, that will be 9x. And then 26.6 minus 2.6, that is going to give us a 24. And then divide both sides by a 9. So x is going to be 24 over 9. Of course, does a 3 can go into both 24 and 9. 3 into 24, that is it 8? And then 3 into 9, that is a 3. So this number is the same as 8 over 3. So instead of me writing a decimal, I mean of rounding off to 3, I'll not round off. I'll write it as 8 over 3. And so let me put here as 2, 8 over 3, and then this is a 1. These are special cases where you don't need to round off. Special cases, don't round off. Now I'm looking at the number that is in the denominator. This is the case now we need to multiply by a factor. In this case, that same number that is in the denominator, multiply by it. So 2 times 3, that will give you 6. And then 8 over 3 times 3, that will just give you 8. And then 1 times 3, that will give you 3. And then the empirical formula. Get carbon, this number here, you put it there. Get hydrogen, you've got 8. And then get oxygen, you have got 3. So this is the empirical formula for this compound. So if it is at this level, you would have thought of rounding off 2.6 to 3. It would have given you empirical formula C2H3O1, which is just O. That wouldn't have been very good. Please, these are some special cases. If the number that you've gotten can be expressed in forms of a fraction, don't round off. Special cases such as 1.3333, 1.25, these numbers that you can round. Is it 1.25 or 1.5? 1.5 is the same as 3 over 2. These are cases which you can express as a fraction. Don't round off. Even 1.33, you can express it. Don't round off. Yes. Pardon? Okay. How the 8 over 3 came about. So This is a topic in mathematics which I'll be teaching next time. So let's just say we're going to do it in mathematics, but I'm going to answer it at the end of this class. Is it okay? Okay. So this is the empirical formula for this one. And then we can now look at the molecular formula. So for you to get the molecular formula, what you are going to do is the same empirical formula that you found, C6H8O3. We have got a 3 multiplied by 16, the molar mass for oxygen. Let me just use rounded off value 16. And then we have got 8 hydrogens multiplied by the mass for hydrogen is 1. We've got 6 carbons multiplied by the mass, which is 12. Someone can punch that if you are able to. So that has given me 128. And then what I'm going to do is I'm going to find N. N is given as the molecular formula divided by empirical formula mass. The molecular formula is given in the question. That is 256.26. Divided by the empirical formula mass, the same mass that I've calculated after finding the empirical formula. That's the empirical formula mass, 128. And that is going to give us, let's see what we get. 256.26 divided by 128. If you've found the answer, please, you can just shout it out. So that has given me 2, rounded off to the nearest one number, like it is 2.00. Now, to find the molecular formula, then I found the value for N there. Molecular formula is given as empirical formula and then with N down here. So I'll just get the empirical formula, which is C6H8O3, and then the N, I'll get it and put it down here. So this will give us C12H16O6. So this is the molecular formula for this one, and this is the empirical formula. Is it okay? Someone needs clarity somewhere? All right, so let's yes. Okay, the N, what you do is you get the empirical formula that you found. Find this molecular mass. Find this molecular mass, and then the molecular mass of the empirical formula. Divide it into the molecular mass that you've been given. Then you found N. Is it fine or hanging somewhere? You will not understand. Can you repeat that? Okay. So this molar mass, there's no difference. The molecular mass, this molecular mass that they've given us is basically just the, now when you're talking of molar, molar is meaning one mole of a compound. Whenever you hear the word molar, but we use them mostly the same with you say molecular mass and molar mass. So when you're talking about molecular mass, in this case, it's just the mass of a molecule. Like this one, if we find its mass, getting this values you multiply by the value that you are seeing on the periodic table, 3 times the value on the periodic table, 8 times the value on the periodic table, and then you add them. That's a molar mass because we are talking of one more of this compound. There is no value in front here. If there was a 2, then it's no longer molar mass because we are talking of the mass of 2 of these. But when it is 1, that's molar mass. Now, this molar mass that has been given is the molar mass of the actual compound, but we don't know the compound. That is why we've been given this one. And then the empirical formula mass is also molar mass, but for the empirical formula. So that's the difference. Let's consider this one. What is the empirical formula of a substance that is 40% carbon, 6.70 hydrogen, and 53% oxygen by mass? So this one is just direct. So we'll get to put element, and the elements we have again, we have got carbon, hydrogen, oxygen, and then we are going to put percentage mass. For carbon, we can see that is 40, hydrogen is 6.70, oxygen is 53.3, and then we'll find the number of moles. The number of moles is simply this mass over molar mass. So just divide 40 by 12. That's mass over molar mass. You can do it quickly to give us the values. So 40 divided by 12. What have you gotten? That is about 3.3333. And then this 6.7, we're going to just divide it by 1 since the mass for hydrogen is 1. If you want, you can use 1.008. It will just give us the same 6.70. And then for oxygen, 53.3 divided by 16. That is going to give about also 3.33. So you see the mole ratio in this case, this value and this value, they are the same. That's the smallest. So if you divide, you are going to divide everything by 3.33. So if you divide 3.33 by 3.33, you get a 1. Even this side, you get a 1. If you divide 6.7 by 3.33, that will give you a 2 approximately. You can round off. So the empirical formula is going to be CH2O. This is the empirical formula for glucose, or let me just say for most of the monosaccharides like glucose, galactose. So you look at the smallest number, you look at these three numbers. Which one is the smallest? This one and this one, they're the same. So I'm going to divide everything by 3.33. That's how you get these numbers. Okay, so this will be the last one. 1 gram sample of unknown compound containing only carbon and hydrogen and oxygen was analyzed through combustion analysis and yielded 3.061. Now, when you're talking about combustion analysis, it's simply a method that is used to determine a formula by burning something or by reacting something with oxygen. What you need to know is that when you react any compound with oxygen, as long as it's an organic compound, you're going to produce carbon dioxide and water. These are the two products that you produce. So in this case, we've been given a compound that contains carbon, hydrogen, and oxygen. We don't know how that carbon is. So all we can do is, let's say this compound is X. We don't know it, but we know it contains carbon, hydrogen, and oxygen. When you burn this one or when you react it with oxygen, what are you producing? Every time there's a combustion reaction, you produce carbon dioxide and water. That is what you are going to get. But look, the mass of this one that bent, we bent 1 gram of this compound. Okay, and then it yielded 3.061 grams of carbon dioxide. From the mass of carbon dioxide which was produced, we had 3.061 grams, and then we also had 0.8849 grams of water. Now I want to find the compound's empirical formula. What is the empirical formula of this compound? So we've analyzed the data like this. Now one thing that you need to know is, remember this compound contains carbon, hydrogen, and oxygen. The thing is this, Since we only have carbon on the reactant side and we only have one carbon here, according to the law of conservation of energy, conservation of mass, also the law, one law of stoichiometry says mass cannot be made or destroyed. It will only be converted from reactants to products. So this oxygen is in excess, meaning the whole of this compound is going to burn, and then oxygen, some of it is going to what? Remain. So that means the whole of this carbon is going to be converted to this carbon you can see here. The whole of this hydrogen you can see here is going to be converted to this hydrogen you can see here. So that is the thing on this. So we need to find first the carbon that is on the product and also the hydrogen that is on the what? On the product. And how can we do that? So we've been given on the product we have 3.061 grams of what? Carbon dioxide. In this amount of carbon dioxide, how much carbon is there? So just like we did the first topic, that is just measurements, we are going to multiply. You can see we have got gram carbon dioxide on top. We are going to put gram carbon dioxide down. Okay, and then we want to find the mass of what? The mass of just carbon. So we are going to have a gram of carbon on top there. I don't know if this one even makes that sense to you, but that is what we are doing. So that the gram of carbon dioxide and the gram of carbon dioxide will cancel, just remain with grams of carbon. If you don't want to use this, maybe it might be a bit confusing and such. What you can do is just find the, you can see that in 1 mole of carbon dioxide, how many moles of carbon do you have? You only have 1 mole of carbon. If you look at water, in 1 mole of water, if you have got one water molecule, you have got what? 2 moles of hydrogens. It's different from carbon dioxide. In 1 mole of carbon dioxide, you've got only one carbon. Does that make sense first before I proceed? Is it making any sense? Yes, you are behind. Okay. Let me say it again. If you look at carbon dioxide, when you have got one carbon dioxide, it means you have got one carbon. Just look at the formula. In one carbon dioxide, there's one carbon. But when you've got one water molecule, it means you have got two hydrogens. Does that make sense now? Every time you find one water molecule, it means you are going to have two hydrogens. Every time you find one carbon dioxide, it means you are going to have one carbon. That's what we're trying to say. So I'm going to use the very same mass that has been given for, or let's find the number of moles of carbon dioxide. In that case, maybe to be is number of moles of carbon dioxide. How do you find number of moles? Number of moles is given by mass over molar mass. Hope that is okay. The mass of carbon dioxide given is 3.061 grams. Now, what is the molar mass of carbon dioxide? We have got carbon and oxygen. So we have got two oxygens, and then the molar mass for each oxygen is 16. And then the molar mass for carbon, check on the periodic table, that is 12. So we have got 2 times 16 and then plus 12. Can someone add that? Can someone add? 2 times 16, is it a 32? And then we have got 32 plus 12, which is 44. So we're going to divide by 44. This is molar mass, is given in grams per mole. So this gram and this gram will cancel. The unit for molar mass is in, I mean for number of moles is in moles. That's the mole that will remain. Okay, so you can go direct and punch. What is 3.061 divided by 44? Like this? Okay, so these are the moles of carbon dioxide that we found. Remember that number of moles of carbon dioxide is equal to number of moles of carbon. That means the number of moles of carbon is also 0.069568 moles. These are the moles of carbon. Now we can convert these moles of carbon to mass. How do you get that? We'll just rearrange this same equation that is here. Then that will give us that mass is number of moles times molar mass. Therefore, the number of moles is 0.069568 times the molar mass. Now, the molar mass we are talking about is the molar mass for carbon because we want to find the mass of carbon. So, times the molar mass for carbon, and carbon is 12. You can multiply. The one who gave us the value, just say answer times 12, we see what we get. 0.848. Okay, so I'm going to put here number of moles of carbon just, that is 0.069568, and then I also put the mass of carbon, that is 0.8348 grams. We are done with carbon. Now let's go to water. Let's find the molar mass for water first. I mean the number of moles of water. Number of moles of water is also given by mass over molar mass. So the mass for water is 0.8849 divided by the molar mass. Molar mass for water, oxygen is 16, 2 hydrogens, that's 2, that is 18. So what are we going to get as the molar mass? What will be the value? 0.049. Okay, this is in moles. Now look at this. For every 1 mole of water, how many moles of hydrogen do we have? So these are the moles of water. So I'm going to now get this value, 0.049 moles of water. We are going to multiply. I've got moles of water on top. I'm going to put moles of water down. And then I want to find the moles of what? Hydrogen. So for every 1 mole of water, we have got 2 moles of hydrogen. Is it true? Can you confirm that? Is it true or someone is lost? How is it that for every 1 mole of water, I've got 2 moles of hydrogen? Okay, so this mole of water and this mole of water is going to cancel. The answer is going to remain in moles of hydrogen. So the answer that is there on the calculator, just multiply it by 2. 0.098. This is going to be moles of hydrogen. So I'm going to put here number of moles of hydrogen is 0.098 moles. Now let's find the mass of hydrogen. Mass is given by number of moles times molar mass. Now we are finding the mass of hydrogen in what? In water. Okay, there. So that is going to give us number of moles, which is 0.098, and then times the molar mass. The molar mass for hydrogen is going to be 2. That is because we have got 2 of the hydrogens. If you check on the periodic table, we only have 1, and then that one multiplied by 2, since there are 2 of them. What value are you going to get? 0.196. Okay. Let's remove now some space here. So what is remaining for us to find is the mass of oxygen. Remember, in this compound we've got oxygen, carbon, and also hydrogen. So we found hydrogen and carbon, remaining oxygen. You know the mass of the total compound, and then you know the mass of carbon and the mass of hydrogen. Can someone tell us how are we going to find the mass of oxygen? And by the way, just this value that I've written here, we're just supposed to multiply by a 1, not even by a 2, because we've already used 2 moles. Remember, in this, what we are finding is the mass of hydrogen. We've already said in one water molecule there are 2 hydrogens. So that has given us these moles. So we are just converting the moles to what? To mass. So when you want to convert a moles to mass, we already have more hydrogen. If you want, you can just multiply direct here. We are supposed to have more hydrogen down and then on top grams, so that the more hydrogen can cancel the more hydrogen. And then for every 1 mole of hydrogen, what is the mass of 1 mole of hydrogen? It is also 1. If you check on the periodic table, the mass on the periodic table is given as 1 gram per mole, or if you want, you can say 1.008 grams per mole, meaning that for every 1 mole of hydrogen that you have, you're supposed to have 1.008 grams. So that is what we do. Don't multiply by the 2, because we are only converting the moles which already have to mass. So the same moles which we have, they are going to be the same mass that we are going to have. Now the question I asked, how are we going to find the mass of oxygen that is in that compound X, since we know already the mass of carbon and the mass of hydrogen? I don't want to use the same formula to find the mass of oxygen. Why? Because on the reactants we had oxygen here, we also had oxygen here. So if we want to use the same formula, and you can see that even on the product we've got a lot of oxygens, so we can't use the same formula that we've been using for carbon and hydrogen. So to find out the mass of oxygen, it will simply be the total mass of the compound, that is 1. We are going to remove the mass of carbon that has been converted. The mass of carbon we have got 0.8348, and then we are also going to remove the mass of oxygen, which is 0.098. So someone can punch that, we see the value we are going to get. Who has punched? 0.0672. This is in grams. So we are going to now put mass of oxygen is 0.0672 grams. Now let's convert this to moles. So number of moles is going to be mass over molar mass. So the mass of oxygen we found is 0.0672, and then the molar mass of oxygen is 16. And then divide that answer by 16. What is it giving? Yes, 0042. Good. So number of moles of oxygen is 0.0042 moles. Now that we have got these values, we can now calculate the empirical formula. The very thing that we did earlier, now I'm going to write, I can now remove the space which is here. We've already used the data. I'll put element. We have got 3 elements: carbon, hydrogen, oxygen. And then I'm going to put their moles direct. So the moles of carbon, if you check, that is 0.069568. The moles of hydrogen, if you check, that is 0.098. The moles of oxygen, that is 0.0042. And then now you can find the mole ratio. So just look at the smallest number of these you can see here. So this is 0.06, this is 0.09, this is 0.00. So this oxygen is the smallest. So we're going to divide everything by 0.004. Starting by itself, 0.004 divided by itself, that will give us a 1. And then we'll go 0.098 divided by 0.0042. 23.333. Okay. And then 0.069568 divided by 0.0042. 16.563. So this one, if we wanted to round off, well, the 23.33, we've seen the threes are repeating themselves and repeating like that. We can convert it into a fraction by saying let x be equal to 23.33. I'm going to multiply by 10, so that will give us 10x is equal to 233.33, since the threes are repeating. And then you subtract 10x minus x, that will be 9x. And then 233 minus 23, that will give us 210. And then 210 over 9, that will be about 70 over 3. Though these atoms are so big like this, so this one can just be rounded off. That is going to be 17. And then this is going to be 70 over 3. This is going to be 1. Then now you can multiply everything by 3 that you can see there. 17 multiplied by 3, that is 51. Yes? Okay, 51. This is 70, and then this will be 3. So empirical formula in this case is C51, and then H70, and then O3. So that is how you go about it. Though it's very rare that you'll be using such big numbers as this, which you can see here. Since this question looks a bit trick, we can, to just make sure that you've understood, let's also use this one. Okay, we can use this one, which is here. We see how much you've understood. Caproic acid, which causes socks to smell, is made of carbon, hydrogen, and oxygen. If you combust 0.225 grams of this acid, you will get 0.512 grams of carbon dioxide and 0.209 grams of water. What is the empirical formula of caproic acid? So we're going to start. We don't know this compound. This is X. If we combust it, we burn it in oxygen. We are going to get carbon dioxide and water. So how much are we burning? If you combust 0.225, so we're burning this one 0.225 grams. And then how much are we going to get? We are getting 0.512 of carbon dioxide, and then 0.209 grams of water. The first thing, let's find the number of moles of carbon dioxide. That will be mass over molar mass. So the mass of carbon dioxide, 0.512. Over molar mass of carbon dioxide, carbon is 12, oxygen is, that is 44. So we can divide that, we see what we are going to get. What do you get? 0.01164. Okay, we know that the number of moles of carbon dioxide is going to be equal to the number of moles of carbon because are in a ratio of 1 to 1. So number of moles of carbon is equal to 0.0164. This is in moles. So to get the mass of carbon that is used, 0.0116. Yes, that is it. I left out something. Okay, now let's find the mass. Mass is given by number of moles times molar mass. So the number of moles is 0.01164 times molar mass for carbon, that is 12. So let's multiply by 12. 0.1396 grams of carbon. So we know the mass of carbon and the molar mass for carbon. And then we can go to water. Number of moles of water is going to be mass of water given, which is 0.209 over molar mass for water, which is 18. So let's get to divide that. 0.0116. It's the same as the other one. Alright. And then that value that you found, to be able to get the mass now. Okay, before we get the mass, let's get the number of moles of hydrogen. We know that for every 1 mole of water, we have got 2 moles of hydrogen. So this answer that we have is the moles of water. Multiply it by 2 to get the moles of what? Of hydrogen. Because for every 1 mole of water, we've got 2 moles of hydrogen. So this answer times 2. What will be the moles of hydrogen? 0.0232 moles. And then let's get now the mass of hydrogen. So mass of hydrogen is going to be number of moles times molar mass. Now the number of moles is the same value. The molar mass is the same one you can see, which is the molar mass for hydrogen is a 1. So if you multiply 0.023 times 1, it will just be the same 0.0232, but it will just be in grams. So we know now the mass of hydrogen and the mass of carbon. Let's find the mass of oxygen. We'll get the mass of the total compound, that is 0.225, and then minus the mass of carbon, which is 0.1396, minus the mass of hydrogen, 0.0232. What are we going to get there? At 0.06 grams. Now let's find the number of moles of oxygen. Number of moles of oxygen, that found divided by 16. What do you get? So if you divide that by 16, we are going to 0.003. Is it the same? Is that what you've gotten? So these will be the moles of oxygen. Now we know the moles, we can now go and find the empirical formula. So we have got first element, the elements that we have, we've got carbon, hydrogen, oxygen, and then the moles. In this case, we don't have the percentage mass. For carbon, the number of moles is 0.01164. For hydrogen, the moles are the same, 0.0116, and then for oxygen, that is 0.0039. So amongst these, which one is the smallest you can see? The last one is the smallest. So divide everything by 0.039. So if you divide by itself, it will give you a 1. And then take in this. What do you get? Divide 0.011 over 0.003. You found what? 297. Try to divide again. Confirm what you found. Yeah. 2.97. It will be the same with this one because they are basically the same. So this one you can just round off. This is a 3. Even this one is a 3. And then this is the 1. Therefore, the empirical formula is 3 and then H